to conclude this section, we come back to absolute maxes and mins and how to find them. So let's take a look here to find the absolute max or min of f of x on the interval a to b. All right, so one thing to notice here, when it comes to an absolute max or min, a typical function will shoot off to infinity one way or the other. Most functions that we look at don't have an absolute max or an absolute min, or maybe they have one but not the other, and so that makes problems not nearly as interesting in one sense and very difficult in another sense. If you don't have the graph, how do you show that something does not have an absolute max or min? Okay, so what we're going to do, and actually where this is going to go in a later section, is to find the absolute max or min just over a certain interval or domain of f of x from a to b. So we won't allow the domain to be all real numbers where it otherwise might be. We're going to limit that domain and just look at it from a starting and ending point. Okay, so here are the steps to finding the absolute maxes and mins, and you may notice that it begins with critical numbers. So we find f of c for all of the critical numbers c that are in that interval a to b. So there's really two steps going on here, and it's just kind of said as one step. We first have to find all of the critical numbers. Okay, so that's like one thing, right? Find all the critical numbers, and then once you have the critical numbers in your interval, then go back and plug them in and get their y values. So this is really saying find the y values of the critical numbers in AB. Once you have those y values, we also want to look at the endpoints. Okay, so remember that thing about the endpoints from the beginning of this section. Endpoints are possibilities for absolute maxes and mins. So if the endpoints are a and b, we want to find the y values there, f of a and f of b. And at that point, we're pretty much done. It's just a matter of identifying the answers. So in step 3, looking at all of these y values of the critical numbers and the endpoints, the largest of those is the absolute max. The smallest of those y values is the absolute min. So what we've done in these previous two steps, these are all the interesting y values. So we're finding, all right, what are the y values for the criticals? Okay, those are interesting. Note those, because those could be local maxes or mins. What are the y values of the endpoints? Those are interesting because they, even though they wouldn't show up here, the derivative might not be 0 or something, but those could be absolute maxes and mins. Right, so we got to look at those too, and then we say, okay, out of all those y values, then let's pick the biggest and the smallest. Let's see it in an example. Find the absolute max and min. So we've got this function here. F of x equals x to the 4th minus 2x squared plus 7. And the interval is just from -2 to 3. So we only care what's happening between -2 and 3. All right. Well, so it begins with the critical numbers. Okay. Take a derivative. When we get to this point in the applications, kind of a joke amongst calculus students is if you're not sure what to do to begin a problem, it's probably to take a derivative. So we got to find the critical number, so we need the derivative for that. And we know there's two types of critical numbers, where the derivative equals 0 and where it does not exist. So let's look at those. And all right, so we'll just talk through these one at a time. Set our derivative equal to 0. Hey, right there, we can factor, right? 4x times x squared minus 1. Hey, we can factor even further. Difference of squares. 4x times x minus 1 times x plus 1. And boom, we got three critical numbers: x equals 0, x equals 1, and x equals -1. Okay, we also have to consider when the derivative does not exist. Don't skip this. It's easy to slip your mind because a lot of functions you're going to look at, it's going to be a none. But don't get in the habit of just thinking, oh, well, it's none. Because what's going to happen on that, that one question on the quiz or that one question on your final, it's not going to be none. And you're going to miss it, and that's going to throw the rest of the problem off, and things won't make sense. Okay, so we got these three criticals. Why is it none? Well, again, we have a polynomial, so we're never dividing by 0. No problem, none. All right, so we found the criticals. Also, we want to reflect on those. These all fall between -2 and 3, right? 0, 1, -1. All of those are in the interval. I'm going to show you guys a quick example when this is done of what you would do if one of these did not fall in the interval. But here they all do, so we're considering all of them. All right, so 0, 1, -1. What do we do next? We're not done with step 1 yet. We need to find the y values for those criticals. Okay, so let me slide this up. And actually, I'm just going to show you. You're going to see the final answer there. Ignore that for the moment. Okay, so we find the y values of all of our criticals. So what are we doing? We're taking each of these numbers, plugging it back into the original, right, to get the y value. F of 0, f of 1, f of -1. So here they are. F of 0 is 7. It's not too hard to see. F of 1, even that's not too bad to compute. Take a moment, verify these calculations I recommend for you to do. F of 1 gives you 6. And because the even powers, f of -1 also equals 6. Okay, so we got the y values of our criticals. Now we can move to step 2. Really, step 1 is the big one. Okay, when we get to step 2, now we find the y values at the endpoints. Well, the endpoints were -2 and 3, so we want to find the y values there, f of -2 and f of 3. And if you plug these back into the original function, you'll get 15. And 3, you'll get 70. So, once you have this list, well, the problem's pretty much over. The absolute max is the biggest, which is 70. The absolute min is the smallest. Now, these happen to tie for the smallest. No problem. If they tie, then it's just the y value I care about. 6 is the absolute min. All right, I'm gonna do this on Desmos, so that'll be available for you guys. And we got our answer. Pretty cool. Okay, let's go back and look at that case. Hey, what if we were to end up with a critical number that's not in our domain? So I'm going to use the same function, but change the domain a little bit. So still f of x equals x to the 4th minus 2x squared plus 7. But now let's consider the interval to be 0 to 3. Shorten it up, tighten it up a little bit. So we'd look at this, be like, okay, there's our function, there's the interval, and we'd start to find the critical numbers, right? So we would find the same critical numbers, 0, 1, and -1. But then, before we moved on from there, we'd reflect and be like, okay, 0, hey, that falls in between. Actually, it's this endpoint, but that's fine. You know, we need to find the y value of 0 anyway. 1 falls in between, so that works. -1, -1 doesn't fall in there. Okay, So we don't care about it. We can ignore it. It's like it doesn't even exist. So we're just going to be like, no, don't worry about it. Completely ignore it. Then when we move on, we say, all right, so the only two that we care about, 0 and 1, let's find the y values there. And then in this case, we already, when we go to the endpoints, we already did 0. So, all right, well, we just need to do 3, and it's 70. And so these are the only y values that we're going to care about. And of course, here the absolute max is still 70. The absolute min is still 6. But, you know, this could have, you know, led us astray. It could have led us to a different answer, obviously. The moral of the story, any criticals not inside your interval, you can just ignore. Okay, that's the end of 4.1. Good luck with homework.